Okay, let's see chapter 2 and quickly recap what we learned last time. So last time we learned about very basics about how we program and also how we define the variables in R. And we talked about the data types like data frames, vectors, and list or matrix. And then we briefly talked about the coercion, whether we convert numbers to characters in certain situation. And also we talked about the index system, which is very basic things when you do programming. So we use the numerical values to put variables in the vectors or data frame, then we can easily extract that information using the numerical system, right? So if you use the vectors like in here, you use the numbers in a one dimension, then you put 1 to certain numbers, then you can retrieve values stored in vectors. But in data frame situation, you use the two-dimensional system and you use the numbers for rows and columns, then you can easily retrieve the information as well. And in this example, let's say using index is like subtracting information you might looking for or certain conditions, then you can use that information to get certain rows or columns. So index use that purpose. And you also learned about the true and false system, which is whether you ask a logical statement. If you have certain statements, then if the statement is true, then you also get a subset for that rows or column matching to that information. So that's also based on the index system as well. And one more thing you might want to remember is the factor. So factor is like character you see from the data frame, but it's actually a bit different from the character system. So factor in a bottom line, you store the integers as a level, then you matching that level to certain variables. So you can easily compare the variables to the level of that information. So in terms of the computational point, this is way more easy method to get a the low memory and also the computationally less burdened system. In other words, we call the memory efficient than other storing system, like storing all the characters, because factors is basically you use the numbers as a index, then you matching that information to character, then you can easily tracking that information in your computer memory, right? So if you go to the R Studio, let's see the situation we can use the factors from your mother's data frame. Let's look at the DS Lab package. Then we get the data here. So we have the data is here, right? So if you open up the data in a separate viewers, then you can see several columns as we see in a class and also tutorial. So if you look at the states, we have different state names like in Alabama, Alaska, Arizona, blah, blah, blah. And you have the abbreviation and you have regions and you have population. Then your first look in this data frame, the first columns is matching to characters, right? So we can easily say this is character. And if you look at the population column, this is, it's a numbers, right? So, I mean, we can instantly say this is numbers or integer. It's quite obvious. But if you look at the regions here, this looks like characters, right? But if you search that information in console, let's say models and region, then you can see that there are characters, but it actually represented as a levels, right? So it has the 4 levels. So from the northeast, south, north, central, west, right? So it has the 4 levels, right? So how we can define, how we can know this definition. So let's look at the class. So if you look at the class of the region column, it says factor, right? But if you look at state, it says character, right? So this is different. So why we have to use factors in this situation? So for instance, like a state doesn't have the duplicate entries, right? So all of the items or the values in this column are the unique values. So it's all like a different state names. But if you look at regions, it has sort of the category or group, right? So it representing, certain, list of states that belong to certain regions. So you can basically categorize states names into the region. So in other words, we can do the categorization. So this case, it's more easier way making categories or groups in a computational view, because computer doesn't have to remember all the characters, right? Computer has to remember the certain groups you are referring in that column. So you use these 4 different regions to representing the levels, then you use that information into your analysis. That's very memory efficient way in a computational point, right? So how can you know about the levels on here, right? So type levels and you type models and regions. Then you can get easily how many levels here? 1, 2, 3, 4, right? So north, south, north central, and west, right? And as I mentioned, that this is sort of the numeric system onto characters, right? So factors is basically matching numbers to character. So if you try to convert factor information into numbers, it's actually possible. So let's do as numeric. Then you can see that the regions appeared as characters that changed to numbers on here, because as you see here, the south is the second item, right? So it changed to 2 on here, and the central west is appeared in full system. So if you look at, sorry, it's not central west, it's west. So if you look at the west, then it changed to 4, right? So basically, if you're trying to convert that information into the numbers, it automatically changed to the factoring numbers, right? But these things is different when you use the as numeric in characters, right? So this basically give you different character. It's basically give you the numbers, so it's going to convert to the NA, which is not applicable, right? So this is different system than between the factors and character. So why do we care about the factors in our analysis? The first thing is, again, it's memory efficient way. And also the second system is making category is very, straightforward approach to draw plots or do some calculation, because if you have certain groups or categories, then you might want to calculate certain statistics based on the group differences or based on the the group changes. So you want to use having that information in your analysis. The factors is kind of very easy way you can represent that group information, right? So factors is one of the the core things you might want to use in the analysis. Okay, so that's the one. And also you can basically create the factors if you want. So this is like you do factor, right? As factor, then you can put the character information in here, right? So as factor, models and states, then you can define factors in the column. But this case, we have all unique information in a column, so there's no point we have to use the labels in the code, right? So I mean, theoretically, you can define factors from the character information, but there's no point. Okay, so that was it, and we can try a bit different things. So you can basically try to make vectors from the vector, right? So how we can do that? You do apple here, and orange, and apple again, and banana here. Then you define A like this, right? Then you can do vector and A, right? So it's changing to vectors, right? So it, vector order, in other words, vector levels is from apple, banana, and orange. That's alphabetical order, right? But you can change on your own definition. So let's say I want to put orange first because I like it. So you can do in this way. So the case, your level is going to change, right? So you define orange first, and apple and banana, right? So this case, you basically change the information for based on your factor information. Okay, so how we specify factors in certain information. So probably one of most usable situation for factors is drawing plots. So we're going to cover the drawing information using ggplot in few weeks. And some of the situation we do factors, especially when you draw the colors, right? So if you look at here, so this is one way you can create the bar plot using ggplot, right? So this is just one typical ggplot. So here is this is probably the drug use by amount. So you put in a dose, right? And this is probably length. So anyway, you have the two groups, which is represented as factors, right? So one group called VC and the other one called OJ, right? So in this example, you use the first level OJ and the second level is a VC. And you basically put the first level and second level and it's matching to sort of colors, right? So VC on here and OJ on here, right? So this is kind of simple situation. You define only two groups for the color selection. But in the case you trying to do multiple groups, like let's say you have 8 groups for defining the colors, right? In that case, you might want to reorder colors by your purpose or by certain definition, right? So one example I can give you as the variant. So let's say we learned about the variant in a genetic course, and we learned about which variant is the coding variant and which variants are non-coding variants, right? And this is sort of a very basic definition of how we define genetic variant in a patient's data set. So once you have the genetic variant, which is an allele, then you're going to have different definitions for the variant, right? So either you can have the stop loss or frame shift, which we learned as a protein truncate mutation, right? Which is the most powerful impact on human biology. And another mutation we can easily think about is the missense mutation on here. This is the variant changing only one base pairs, and it changed one amino acid in a protein sequence, right? This is sort of the second largest impact on our disease or human biology, right? So this example is all from the coding variant, right? But the variant like a splice change or UTR variant or whatever the regulatory variants, those variants from the non-coding regions, right? So as we learned in genetics, the mutation happen outside the coding regions. Those are from the non-coding region, and we call that this is the non-coding variant, right? So if you have the list of the mutations belong to these categories, right? And you put it into the bar plot situation like you use in ggplot in here, then if you don't set up the factors in your data set, then you're going to have the alphabetical order of the levels, right? And you're going to have the colors matching to the alphabetical orders, right? And the question is this really accurate for the data representation? And it's not, right? Definitely it's very bad decision, right? The reason is that if you set up the mutation interpretation, you have to think about the differences between the coding variants and non-coding variants. So in that case, you have to make a order of the mutation consequence by coding, at least coding and non-coding. And within a coding variant, you might want to make an order by the impact, right? Whatever it's a frame shift mutation, protein truncate mutation, or missense mutation. There must be an order of the mutation in your analysis, right? So this case, factors is super useful because you can set up the orders, right? So like you set up the factor and your data is called DF and it's stored in a consequence, then you can set up the order, right? So whatever you do frame shift first. Oops. Then you set up the top lost and you set up the missense mutation. And you can set up your own definition for factors, right? So in that case, you can make a numbers, you can make a levels, then you can use that information into the visualization like a ggplot or your analysis. So factors is very useful and also very important information in your R analysis. Okay, so we might have some questions about factors like let's say you have a apple, orange, apple, and banana, and when you set up the factors, you omit, so you basically miss one of the entries you use in vectors, and how factors going to be set up, right? So you basically use the same A appeared in here, and you set up the levels only for orange and apple. You totally missed out banana. And is this working? Let's try. So it's working, but it's not exactly working as you expected, right? So it's basically give you a outcome, but this is not you want, right? So you put the levels here like apple, orange, apple. It's correct. You have two levels on here, but banana is missing. So it appeared as an NA, right? Because you didn't set up the level for banana and your factor comment not going to include this banana in your factor transition, right? So this is the one thing you have to be really careful when you use factors in your analysis. So in a future situation, you probably be in a situation where you have to put factors for your analysis. And I think I assume that this is very routine things in your R programming. But one of the common mistake people doing in R in factor situation is the missing out one levels, right? So you have to super careful about whether you miss some levels or not, right? So one good things about setting the factors properly is when you set up the factors like in here, then you can check whether there is any NA in your whether there's any NA in your vectors, right? So it has only one, right? So here, the NA is happen. So you assume that you don't have the NA in your input, but your output has NA. So you expect that, oh, there must be something wrong in my vector transition. So you can check in this way. Or what I do is I do like this situation. So I make a unique entry. So A is basically have apple, orange, apple, banana, but I make a unique things with the comment called unique. Then I use that information for my vector setup, right? Like in here, right? So you can basically set up vectors easily, right? So how about this? So you don't use the unique vectors for setting vectors and just using all vectors you use for vector transition. How these things will behave, whether working or error. Let's try. It's going to be error. The reason is that if you put the duplicate things on levels, and vector comment will not accept that information. So it's appeared as error, right? So how can you know about there's any duplication in my vectors? So there is one comment called, duplicated, and A, then what has the duplicate information, right? So apple, orange, apple, banana, right? And the third item called apple, this is the duplication of the first one. So you basically have two apples on here, but only one thing has the duplicate things on your vectors, right? So first one, the original one will be kept, right? So if you want to remove the duplicate things, you can modify, you can tweak that comment like this, then you can have it, right? So this is basically same as unique comment, but yeah, there's another way you can remove the duplicate. Okay, so that was about the factors. And we also can do plot and about R base comment, but using the R plot information in your the R analysis is you do some time, but it's not very frequent, because once you know about the ggplot, then all of your visualization exercise will be based on ggplot. So I mean, you can quickly try plot things in your R base. It's fine. Plot comment like this is the easiest way. You can put X, Y, the two-dimensional information, or sometimes just one. It's fine, but R has better system called ggplot, and your plot and your visualization system will be totally geared by ggplot command line. And we'll cover in coming weeks. Okay, so that was about the chapter 2, and then move on to chapter 3, which is the programming basics. And what we're going to learn today is the why we have to use programming, especially in biology. And we're going to go through some of very basic things about the programming exercise, like setting up the conditional expression, setting up the defining functions, namespaces, and for loop functions, or vectorization and functionals, right? So what is programming? So as we discussed last time, so programming is basically when you have certain purpose or certain aim, then you ask computer to do that task for you, right? So the easiest programming we might experience in our life is to doing the toast, right? So when you bake the bread in the morning, then you can just put the bread on a machine, then you press the button, then toast machine will remember the time and temperature, then that will give you the sort of baked bread out of certain time, right? So this is such an easy programming way. But the computational programming is much more complicated than this, right? So you set up the proper programming language and you driving the hardwares and also softwares, then make a certain purpose in scripting, right? So in that case, you have to know about certain computational language. That's why you can communicate with the machine, right? So in early days, people has developing some, the computational languages like a C or like a Bash or whatever Fortran things. But these days we have very specialized languages to operate the machines like Python or MATLAB, as I give exemplified last time. So for certain data analysis, or especially for the genomic data set, we mostly use the R programming or the Python system. Then you can easily operate the computers to do that purpose, right? Or more recently, the deep learning or the AI things is quite, become common in many of science, and also will, not will be, it's already biology as well. In that case, you use the Python language because the Python is quite powerful to operate the neural network, the deep learning system, and you can easily use many different programming already implemented in a deep learning purpose. So that case also we do the programming as well. So programming, as I mentioned, that this is the process of creating a set of instruction, and that will tell a computer about how to do that, right? So you can use many different programming languages, like, as I mentioned, that you can use R, Python, MATLAB, Java, Perl, NIM, Julia, many things, right? But, we go for the common things first, right? So you use R or Python first. In this class, is mostly R. And also non-inclusive discussion of programming languages. So this is sort of the philosophy of how we use the programming language in our the biology research. So if you are super keen on that information, then go to the link. Oops, not this one. Link the URL and go to here. Okay, I will accept everything. Okay, so this is the sort of the common rules for the biologists learning programming. And I found this is quite useful. So, if you're super keen on the, want to be an advanced programmer in a biology system, it's definitely for you. Okay, so that's for your learning. Okay. One of the things we do commonly, so here we means that the my lab, or at least the genomic part, this is one of the common things you do in your experiment. So when we try to find the mutation from the patient, we basically collect the DNA samples, right? So we collect the samples from the patients, right? And mostly blood, but if if there's any access to the tissues or cells, we also collect the samples as well. So we collectively call those samples, right? So we got a samples like a DNA or RNA. Then we do the sequencing as we done in as we learned in a genetics class. We use the NGS machine like Illumina, then we do the sequencing. So for example, we do the whole genome sequencing, and we have at least 30 depths of the reads for the patient blood samples and DNA, and we got a sequence read information. And you know that this information is stored in the FASTA-Q file, right? And once you get the FASTA-Q file, then you align those reads, FASTA-Q reads into the alignment format to the reference genome, then we make a SAM or BAM file. And once we get that file, we call the variant, right? We do the variant calling, and we get the list of the variants for each patient or each samples, right? And we know about that, the file type, we call the VCF, right? So we're going through this process. This looks quite simple, but it actually has many different processes. So it has from the FASTA-Q file and to the unmapped to bridge BAM, and you do the map to bridge, which is called CRAM, and you create the individual VCF file from the variant calling process. Then you get the VCF file for each individual. We call the GVCF or just simply VCF. Then once you get the control matrix, then you get a final VCF, which is the joint VCF, as we learned in a genetics course. And this is very simplified process. We get 4 different steps, but in reality, we have developed the process. We have at least like 10 different stages. Then we process this GATK analysis, and this is the one full, the workflow of how we find the mutation from the patient, right? So all of that process, you have to use the programming language. Otherwise, you're not gonna get any information, right? So what I mean is you get a sample, and you run a sequencing, and you get a FASTA-Q file, and these things is like a human label. You do by hands, right? And after that, you get a FASTA-Q file in your computer, in your computing server. Then you have to process all of these stages by programming. So you have to tell computer what to do, right? You have to tell computer, we're going to change this FASTA-Q information into the alignments. You have to type certain programming language to operate the computer system, right? Then once you do such activities over different stages, like at least 4 stages on here, then you get a variance. Then you use the variant information into your analysis. That case, you also have to use programming language as well, right? So what I want to tell you is I want to explaining this entire process. What I want to empathize is we have to know about the programming. To go through this complicated level of exercise to achieve the mutation information, which is the VCF file, right? So learning programming language is an essential thing to communicate with computer, and you want to hand on that information into computer and easily, then you can speed up all the process, then you get a outcome out of this, right? So this is one very good information about how we use computational things in a programming exercise. Okay, so in this programming exercise, we have several sort of common backgrounds using that information. So one thing is, I don't know why it's a little bit chopped. Let's look at it like this. So first thing is the conditional expression, right? So computer basically take a logical statement. So you ask something for computer, and computer will perceive that's true or not, right? So this is basically like you give a Boolean information. So in other words, we call the conditional expression, right? So you basically ask computer whether this is true or false, right? So conditional expression is one of the basic features of the programming. And this is, we call the flow control, right? So in a computer situation, computer's perspective, you give something, then computer say whether I have to go further or not, right? So that case, computer, simplify the situation into the, Boolean statements, like whether it's true or false, right? So if that is met to true, then the computer will proceed with the task matching to true situation, right? So for that purpose, one of the most common conditional expression is the if-else statement, right? So let's say how this thing is working. So if you go to RStudio, get away. if you look at if-else situation, so let's say we define A is apple, then you ask if A equal to apple, oops, then you give something to computer and print yes, right? So let's see here. So if is the situation you ask certain conditional expression. So conditional expression is A equal to apple, right? So A equal to apple, right? Then computer knows that A is an apple, right? Sorry, A is apple. So it says true. So if that statement is true, then you will ask computer to do something, right? In this case, we call print yes, right? So computer easily do this, right? But let's say if that is not the case, then you say, no, it's not apple, right? Ooh. That's great. Lovely. Okay, so we have to put different things, right? Let's say here, banana. Oh, no, this is much easier way. So banana, right? So let's do this. Then they say, no, it's not apple, right? Because we define A is banana, right? So the computer say, this is not true. So it goes to something else, right? Which is the false situation. Okay, so this is the very basic things about asking the conditional statement, right? But in real world, one of the most commonly used functions in a conditional expression in your R programming is if-else, one-line comment, right? So you can put if-else like this separate system, but you can also do like this, right? So you can basically ask conditional things on here, banana. Then you set up the true things on here. Yes. No, no, it's not apple, like this, right? Oh, sorry, has to be apple. So you can basically shrink the if-else in a one-line comment, like in here, right? So this is very useful situation. Okay, so why we have to have two different systems, right? So one-line comment if-else looks much easier way than separate if-else, but why we have to get two different systems, right? Sometimes functions has two different system, looks duplicated, is fine because the programming is the evolving system. So sometimes you have redundant way to do the same thing, but and sometimes you have different purpose. So let's assume, let's try this. So let's define A, apple, banana, and peach, right? Then let's try this. So we set up the vectors, a series of characters, right? Apple, banana, and peach. Then you ask this. So how about this? So if you ask A equal to apple, then it will turn up as an error, right? So condition has length greater than 1, right? So why that happen? Because you have 3 different entries in a conditional system. So if you want to use a separate statement, then you have to ask one thing at a one situation. But if-else is different. So if-else basically asks 3 times, right? So first one is yes, because we define apple on here. And second one is banana. And the third one is peach, right? So this if-else and one-line if-else is very different in terms of whether you can ask, multiple entries in vectors for the conditional statements, right? And also, in other words, you mean that mothers and region. Let's look at here, right? Then let's try this. If mother region is south, then you say print south. Okay, not south. Yay, south, right? And this is not working as expected because the mother's region has multiple items as well. So if you use if as like this, mother's region south, yay, and here is nope, right? Then you can apply this if as across the rows, right? So why this is very strong, right? You can set up the new information like this is south, right? And you basically tag that, the one line comment to ask conditional statements across rows, right? So not just one point, you can ask across the columns, across the rows, right? So this is very efficient way because you don't have to ask every time. You don't have to ask repeatedly in every rows. You can just apply across the rows, right? This is very quite unique and very strong point in terms of our using, because this is the situation we call the vectorization, right? So we a little bit jump on this topic. So vectorization is basically means that you have the vector system like you have in this column, right? So this column we call the column, but that information is actually vector, right? So you can if you use the vectorization, or if the vectorization is implemented in a certain class, you can basically use functions within vectorization, right? So if first is the vectorization enable function, right? So you can ask the conditional statements and do certain tests across the vectors. So this case we say it's the vectorization, right? If you don't have the vectorization, what you have to do is you have to ask this if-else situation in every rows, right? So how we can do every rows? So for, right, you do for loop 1, 2, and more mothers, right? Print I. Oops. Where am I here? So what I've done, what I did is how many rows in model data frame? We use the n rows column, right? And if you type that, it has the 51 rows, right? It has the 51 rows as in here, right? Then you use the seek function, which will make a numbers from 1 to this range, or you can set up like a 10 to something, then you create 10 to something. But here I want to make a 1 to the end of the rows, right? Then here I use the for loop, which is you iterate each entries within the vectors, right? So vectors on here is this, right? 1 to 51, which is representing rows. And you use that information and you take out each item at a one time, then you print it, right? Print I. So what I want to tell you is if you don't want to use if first one line comment, then you have to do if at a one time, right? So what I can do is mothers and region and I, right? And that will give you the items, right? So you can ask if equal what we did, south, right? South, print, yay, as no, right? So you have to write down code like this way. So you type that, then you get a yay, nope, nope, yay. You have to iterate 51 rows at one time. Then you ask this in each row, right? So this is quite different from the if else one line comment, right? So how we did like this. And if you look at the code, this is much simplified way than this nested the for loop, right? So that's the difference is in terms of the code writing, but also this one line comment we call the vectorization, and this is just a loop. So if you use the loop, it's much more slower than vectorization. So we only do 51 rows this example, but let's assume that you have like 3 billion rows as we have in DNA, right? So if you have huge amount of numbers in terms of your process, then loop is always very bad situation. This is very slow, right? So this is one example. So here is the number of calculation. So in a real world computational things, you're not gonna do like a 10 different calculation or 100 different calculation. You're always dealing with like thousands or millions or billions of calculations. So that case, vectorization takes like a seconds, right? The loop is linearly increase the calculation speed, right? So loop is quite slower than vectorization. And why that happen? So the reason is that loop is basically like loop is like a situation computer doing something in every situation. So computer basically take the loop at each iteration. So computer takes one loop, second loop, and third loop, and it has the task on each iteration. But vectorization is different. Vectorization is basically applied function in a one shot across the rows at one time. Then it will get information out of these vectors, right? And also vectorization already used the system called index, right? So as we learned in chapter 2, right? So index is like a computational physical address rather than the human perspective address, right? This is like a computational address, right? So computer already has the index system within their memory, and if you apply the vectorized functions into this index system, computer taken at one time. They don't have to think about that because they already have that address in their memory, right? So in that case, vectorization taken advantage over loop. So many of functions trying to use the vectors rather than loop. And why I call this is one of the unique features in R, because R is developed in a way to do statistics and the matrix system computation. So it's already implemented vectorized system in their programming nature. So if you use like a Java or Python, it's more like a one-dimensional system. So they also have the vectorization system, but not like this, the way. So they have different natures in terms of the programming purpose. So if you do the R programming, that means that you have to fully take an advantage of vectorization, and you have to think about your scripting in a vectorization system. That's basically my suggestion, but you don't really expose to that situation because the next chapter we're going to through the tidyverse, and tidyverse, all of the tidyverse system is already oriented vectorization. So if you exercise the R programming in the tidyverse system, that means that your programming is going to be based on the vectorization rather than a loop system. Okay, so that was the explanation about the vectors and loop and conditional experiment. Okay, so we do the one of the common things about the data frame is the subset. So you use the conditional statement or logical way, like you do in a true-false statement in an exercise. You can basically subset the rows, or you can basically subset the columns. And we're going to do exercise with SN2A dataset, but I will put this one in a bit later than tidyverse, because I found using tidyverse is much simpler way to subsetting exercise. So let's put in the coming weeks. Okay, so let's think about the functions. So function is, as I mentioned, that this is the very simplified task. If you want to do something, then you make a orders of task for computers, right? So defining functions is basically you can make a certain comment for yourself, right? So in an R or the R package, there is a predefined functions, but you can also define functions by yourself for your purpose. So let's say I wanted to, let's say we do functions like this. And let's say check south, right? And function is x. Then if else x equal to south, and yay, and no, a and print. Oh, sorry, not. Let's say b. It's a little bit confusing. Check south. Then you put south on here, right? And it's obviously yay, right? So you define functions by yourself, is by your purpose, right? Then the functions appeared in here. Then your x is your input, so you can set up like this, south, or you can do west like this, and it's obviously nope. Or you can do like this, right, regions, right? So it will take a vectors into functions, right? So yay, no, no, yay, yay, whatever, right? So these things is the one of the way you do functions, right? So as I mentioned that there are lots of different functions you can try, right? So we have the CRAN package with the central system for R archive, and also bioconductor, or you can install the package from the GitHub repository directly. So all of that things you can use for installing packages, and that will come up with the tutorials or exercise in future. Okay, and namespaces, I don't think we can cover these chapters because that will be appeared in tidyverse again, so we can touch on this later. Okay, we covered the full loops, vectorization, and why it's faster. Okay, so I think this is all about the chapter 3, and chapter 3 is not that complicated. This is more like a philosophical way. What can we do with the programming language? And more specific things we can try on a language is the tidyverse, which we'll cover in Wednesday. And that will be a really like a start of the joy in our exercise. Okay, so that's all about today, and hope you have the safe holidays, and see you on Wednesday.